let us understand about the covalent bond formation. Covalent bond is a bond which is formed by the mutual sharing of electrons. This is a bond which is formed by mutual sharing of electrons. As we learned in the previous session, the ionic bond or the electrovalent bond is formed by complete transfer of one or more electrons from the valence shell of one atom to the valence shell of another atom. Here, it's not completely transferred. The participating atoms will donate the electrons, equal number of electrons to a common electron pool, and that would be shared among the constituent atoms equally. Now, let us take up an example so the concepts become very clear. Let us take up the example of formation of HCl, hydrogen chloride. How is this being formed? This is formed by a single covalent bond between the atom of hydrogen and chlorine. Now, let us write the Lewis electron dot structure and go in for a proper analysis. Hydrogen is having atomic number as 1 and its electronic configuration is 1s1. Similarly, atomic number of chlorine is 70 and its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. Now, with respect to hydrogen atom, its configuration which would be stable is, it should possess a configuration as 1s2. It cannot take up the configuration as ns2, np6 because it is a small atom. It cannot accommodate 7 more electrons inside it to achieve this status. So therefore, its stable configuration considered would be just if it fills up ns2 condition, then it will be its stable configuration. So how many electrons are required for the hydrogen to achieve this 1s2 or ns2 configuration? It's already having 1 electron in its s orbital in the first shell and it is requiring just 1 more electron. Now let us look at the case of chlorine atom. Chlorine atom in the valence shell, third shell is its valence shell or the outermost shell, and in that it is containing 5 plus 2, that means 7 electrons. So this is again running short of 1 electron to achieve the stable octet configuration as ns2, np6. Now what will they do? They both will donate 1 electron each to a common electron pool and that is being shared among them equally. Now let us write Lewis electron dot structure for hydrogen. Hydrogen 1 electron and Lewis electron dot structure for chlorine. Chlorine atom is containing, as we have understood, 7 electrons. So therefore, the 7 electrons of the valence shell has to be indicated by 7 dots around the symbol of chlorine. Now what will they be doing? They will donate 1 electron each to a common electron pool. Now what happens after donation of this? Now that donated electron is this and it will be shared among the constituent atoms equally. Chlorine is a big atom in comparison with hydrogen. So now let us see how many electrons are there for nitrogen. All the electrons of the circle belongs to this and this circle electrons also belongs to this. So therefore how many electrons there here? 1 and 2. So what is its configuration now? Configuration of hydrogen has become 1s2. Now how many electrons are there for chlorine? 1, 2, 3, 4, 5, 6, 7 and 8. So it has achieved the octet status as 1s2, 2s2, 2p6, all these were already there. 3s2 was also there. Now because of this one addition electron, its configuration has become 3p6. That means even the chlorine atom has attained its octet configuration and the hydrogen atom has attained its 1s2 configuration, which was supposed to be its stable state. So how has this been achieved? By the mutual sharing of electrons. Mutual sharing of electrons. So a covalent bond is a bond which is formed by mutual sharing of the electrons between the constituent atoms. This covalent bond would be formed only by the donation of the electrons by each of the participating atoms. But then the number of electrons that can be donated, based on that we have the different types of covalent bond formation. We learned the example of single covalently bonded molecule, that is HCl. Oxygen molecule, it is bounded by 2 covalent bonds. Nitrogen molecule, it is bounded by 3 covalent bonds. Let us see how oxygen is having 2 covalent bonds. Oxygen, atomic number 8, electronic configuration 1s2, 2s2, 2p4, 4, 5, 6, 7, 8. So this is the electronic configuration of oxygen. So second shell is its valence shell. How many electrons are there in its valence shell? 4 plus 2. It is containing 6 electrons. So therefore how many more electrons are required for the oxygen atom to attain stability? To possess ns2 np6 configuration in its valence shell,